Hello all, today in this video we are going to make a demo with the SGD optimizer with LSTM. Already with the same code we have worked with Adam optimizer, and this is a continuation video of making comparison with Adam optimizer and SGD optimizer. First we are importing the libraries which we are needed. Then the data set which is used is email spam detection data set. This email spam detection data set we downloaded from Kaggle. You can just give us email spam detection data set. Kaggle means you will get this data set. This data set is having nearly 3002 entries, and among that the first 3000 entries, 3001 entry we will be using as the X variable, and the last entry which is the prediction one we will be using as the Y variable. Then we are getting the info of the data set. By getting the info of the data set, it is given that only the one type which is this one, it is object, and all others are integers. And then we are just checking whether our data set is having any null values. You may notice that every values is getting 0 only. This shows that our data set is not having any null values. But if it is having any null values means we have to work with some pre-processing function. Then we are determining the X variable and Y variable. As I said previously, for the X variable we are making use of the first 3001 entries, and for the Y variable we are using the last entry. Then by use of this X variable and Y variable, and the test sizes to 0.2, that is 20% for testing and remaining 80% for training. We are determining variables like X train, X test, Y train and Y test, and we are converting this X train and X test to vectors. For that we are using the standard scalar function. Then we are getting the shape of the data set. For why? Because our input shape, we have to check the input shape, and also this LSTM which we are going to work, it will make use of only three-dimensional data, but you may notice that we are having only two-dimensional data. So we have to convert our two-dimensional data into three-dimensional. For that we are using the reshape function and converting our two-dimensional data into three-dimensional, and this shape only we are using as the input shape. And for that we are giving the layer contributions for LSTM, like it is having sequential layer with the first LSTM layer as filter size is 64, then input shape as the shape of the data set, and in the first two LSTM layers we are using here and here, that is in third line and in fifth line. In the third line you may notice we are having return sequences, but in the fifth line the return sequences is not there. And also two dropout layer we are using in 4 and 6. In 4 we are using the dropout rate with the as 4.4, and with the 6 as dropout rate as 0.6, and finally a dense layer with the output dimension as 1. Why? Because our work is a binary classification work. So if it is a multi-class classification work means this 1 will be replaced by the number of classes we are having. Then with the binary classification work, mostly the activation we will be using as the sigmoid. Then we are getting the summary of the model. So this is the summary of the model. Then we are compiling our model by using the loss function. Loss as categorical cross entropy, and the optimizer as Adam, and metrics as accuracy. Then we are training our model by using the fit function with the variables like X train, Y train and approaches for 5 approaches, batch size as 32, and validation data. So for 5 approaches we are getting the values of loss, accuracy, validation loss and validation accuracy. You may notice that this accuracy is higher when compared to validation accuracy. So first of all we will be working with all the available optimizers with deep learning, and we shall in the end make some text to just work with this accuracy, that is validation accuracy to make better than accuracy. Then we are making the classification report. By this we are getting 68% accuracy. Then we are making a definition for the confusion matrix, and by this we have plotted a confusion matrix. So next we are working with the SDD optimizer. The only difference between the layer contributions and all same only, but the name differs. Previously it will be LSTM, now it is LSTM. Yes. Why? Because while making comparison, if we are making the same name, means it may create some issue. So only we have changed the names, but all others are same only. And also here everything is same. The name is only differs, and also this optimizer it will be replaced by the SGD, and it works for nearly 5 approaches. And we have got the values for loss accuracy, validation loss, and validation accuracy. Here also we are getting 68% accuracy only as Adam, same as Adam. Then we are displaying the confusion matrix. Finally, we are making a comparison. Since both with Adam and SGD we got the same accuracy, you may notice that here both lines are merging with one another only. Likewise for loss also it is same only. So this is the difference between Adam and SGD for LSTM. In the next video we will be working with RMS prop classifier optimizer, and we will make a comparison with this and will confirm that which optimizer is providing better results. Thank you.